This time I gave the full voltage to the regulator from power supply and adjust the voltage by changing the values of preset of the voltage regulator. In order to build this bench power supply, you must have this voltage. This is the most important unit of this project. In order to build this bench power supply, you must have this voltage current regulator. It is the main controlling unit of this project. As I have planned to add a battery charging facility, you need overcharge protector module as well. Use a 230 volt on/off switch. You need to use potentiometers. I am planning to remove default presets and add separate potentiometers. You may use multi-turn potentiometers as well. I am using banana jack connectors to get the power out. You may need 4. 2 for power supply and the other 2 for battery charger. Use 2 switchers for programming charging protector unit and use a small volt-ampere meter to display the regulated voltage. Additionally, you may need connectors to make links with each module and devices. This is the most important unit of this project. Without the power supply, there is no bench power supply unit. I am using a switch mode power supply unit instead of a transformer due to various reasons. This is 12 volt power supply and we can use up to 30 amps. The power supply has marked as live, neutral, ground connections. And these are the power outputs. There is a preset to adjust the voltage. We can connect the supply wires first. The voltmeter have 3 wires for power supply. Red wire is to give the power to the voltmeter. The voltmeter need at least 5 volts to power on. Then there is a yellow wire. It is to check the voltage. The yellow wire should be connected to the voltage output which we are planning to measure. As usually the black wire is for ground. Since this module can measure the amperes, there are big more 2 wires. If you want to measure the amperage, you can connect big black wire to supply ground and big red wire is to the ground of the measuring voltage. Since I have planned to connect a voltmeter, I use the same to check the voltage of the power supply. Connect the voltmeter to the outputs of the power supply. You can see when you change the values of the preset, you can increase the voltage up to 15.1 volts. Even though the power supply is 12 volt, there is no issue to use as a battery charger as we can get around 15 volts. Before installing the regulator unit, I decided to check the unit with my power supply. In order to check the voltage outputs, I used the same voltmeter. This time I gave the full voltage to the regulator from power supply and adjust the voltage by changing the values of preset of the voltage regulator module. If you can remember that, the power supply gave us 15.1 volts. You can see there is no voltage deduction from the module as the voltage regulator is also giving the same voltage as an output. I checked the same using my multimeter and confirmed the result as same. Now let's check which one is suitable for voltage regulator module, the normal potentiometer or multi-turn potentiometer. If you compare the cost of both potentiometers, the normally one is around 20 times of cheaper than multi-turn potentiometers. In order to connect external potentiometers, you have to remove the preset installed in the voltage regulator module. Since I want to connect and maintain this unit in future, I used a wire code with connectors. Now I am going to check with the normal potentiometer. Since the printed value of the preset is 103, we have to use 10 kilo ohm potentiometer. After soldering wires correctly, I checked the output voltage by rotating the potentiometer. You can read the output value from the connected voltmeter. I am not satisfied with the result. The voltage is not constantly changed compared to the changes of the potentiometer. You also can see the results by looking at the value of the voltmeter. Now we can check with the multi-turn potentiometer. But, you have to read the pins correctly. Because the pin's location of multi-turn potentiometer is not as same as a normal potentiometer. However, pin numbers are printed on the surface of the potentiometer itself. Okay. Imagine a multi-turn potentiometer like a super precise volume knob but for electronics. So, instead of turning it just a little bit to make things louder or quieter, you can turn it a whole bunch of times to get really precise control. Regular volume knobs are like turning a quarter of the way around, but multi-turn ones are like turning it many times to make it just right. They're like the fine-tuners in electronics, making sure everything works exactly as it should. So, when you need things to be super accurate, like when tuning a radio or setting up fancy equipment, you use a multi-turn potentiometer. It's like the detailed adjustment tool for making electronics work perfectly. So, when you use a multi-turn potentiometer in your project, it's like upgrading to a super smooth volume control. The voltage outputs become way more precise and fine-tuned. It's like making sure everything runs really smoothly and exactly how you want it. So, for your project, I'd totally recommend going for a multi-turn potentiometer. It's like the VIP version for getting that extra level of control and smoothness in your voltage adjustments. Alright, so now, let's talk about the charging part of your project. Since you're adding a battery charger unit, that's like giving your project its own power station. It's a game changer because it means you won't have to worry about running out of juice. And here's the cool part, you're adding separate buttons for the overcharge unit. It's like having a control panel on the outside of your project. Imagine these buttons as your project's command center, right on the casing. Super convenient. Now, you're also mounting a 7-segment display on the casing. That's like adding a mini screen to your project, making it even more interactive and user-friendly. Of course, to make all these awesome features work, we'll need some extra wires. But no worries, we've got you covered. Now, I recommend checking out this video. It'll show you the step-by-step on how to bring all these elements together. Once you see it in action, it'll be a breeze to set up your project with the charger, buttons, and display, making it a complete powerhouse. So, go ahead, watch the video, and let's turn your project into something extraordinary. Now that the buttons are properly connected, the next step is to detach the 7-segment display from the board. Instead, you'll connect the SSD using extra wires. It's like rearranging the pieces to optimize the setup and make sure everything works seamlessly. As this video is set to be an extended presentation, I'll conclude it at this point. Stay tuned with SetNFix for the upcoming segments of this project. Don't miss out on showing your support. Remember to like, share, and subscribe to my channel. Stay with SetNFix.